Assalamualaikum. Today I will present about introduction of piling. Firstly, foundations provide support for structure, transferring their load to layer of soil or rock that have sufficient bearing capacity and suitable settlement characteristics. There are very wide range of foundation types available suitable for different applications depending on considerations such as this is the characteristic of piling. First, the nature of the load requiring support. Number 2, ground conditions. Number 3, the presence of water. Number 4, durability of the materials. Number 5, cost. Number 6, accessibility. Number 7, sensitivity to noise and vibration. And lastly, promiscuity to other structures. Firstly, very broadly, foundations can be categorized as shallow foundation or deep foundations. Shallow foundations are typically used where the loads imposed by a structure are low relative to the bearing capacity of the surface soil. Next, pile of foundation are deep foundations. They are formed by long, slender, columnar elements that typically made from steel or reinforced concrete, or sometimes timber. A foundation is described as pile. Lastly, pile foundations are principally used to transfer the load from superstructures through weak, compressible strata or water onto stronger, more compact, less compressible and stiffer soil or rock at depth, increasing the effective size of a foundation and resisting horizontal loads. That's all from me. Introduction of piling.
So, I continue the presentation with types of pile foundation. Pile foundation is divided into two, by functioning and by installing. For functioning, there are two types. Pile is end-bearing pile and friction pile. While for installing, there are two types, which are driven piles and board pile. So next, pile foundation classification by installing. First, displacement piles or driven piles. Driven piles, also known as displacement piles, are commonly used from a building foundation that provides support for structure, transferring their load to layer of soil or rock that have sufficient bearing capacity and suitable settlement characteristic. A driven pile is a long, slender column made of preformed material and having a predetermined shape and size that can be installed by impact hammering, vibrating or pushing it into the ground to a designed depth or resistance. If the soil is particularly dense, pre-drilling may be required to enable the pile to reach the designed depth. And lastly, driven piles are very adaptable and can be installed to accommodate compression, tension or lateral loads with specifications set according to the needs of the structure, budget and soil condition. Example of driven pile is steel pile, concrete spoon piles, precast concrete piles and timber piles. Okay, this one is displacement piles process. Okay, next type of driven piles. Type of driven piles divided by 4 is steel, precast concrete, timber and composite. First, steel. Standard steel sheet pile section can be used to form box section piles or H section piles. Second, precast concrete. This can be square, octagonal, cylindrical or sheet pile. Third, timber. These are usually square sawn but can also be circular, tapered, treated, untreated and percussion driven. Last, composite. These are piles that use a combination such as a concrete pile with a steel tip extension. Okay, the second of pile foundation by installing is replacement piles or board piles. Board piles, also known as replacement piles, are commonly used from a building foundation that provides support for structure, transferring their load to layer of soil or rock that have sufficient bearing capacity and suitable settlement characteristic. Replacement piles that are formed by creating a bow wall into which the pile is then cast or placed are referred to as replacement pile because existing material, usually soil, is removed as part of the process. And the diagram is the process of both piles. Okay, next, pile foundation classification by functioning. Pile foundation classification by functioning divide by two end-bearing piles and friction piles. For end-bearing pile is this pile transfer their load onto a firm stratum like rock. Soil bearing capacity is low installed end-bearing pile. Prefabricated files and auger types pile can be used. And for friction files carry the major part of loads only by means of friction developed between pile shaft and soil. And this one is comparison between end-bearing piles and friction piles. Thank you.
For this part, I will explain about individual pile capacity. What is capacity of pile? Capacity of pile group is the sum of the individual capacity of piles. Piles are driven generally in groups regular pattern to support the structural loads. The structural loads is applied to the pile cap that distributes the load to capacity of piles group is the sum individual capacity of piles. This is formula for pile group capacity. Q for ultimate capacity of pile group, QO ultimate bearing pressure of footing of area B2, L for length of pile, B size of pile group, and last F for shear resistance. This is example image for pile capacity. The efficiency of pile group depends on the following factors. First, spacing of piles. Second, total number of piles in a row and number of rows in a group. Third, characteristic of pile like material, diameter, and length. The reduction in total bearing value or group of pile is more in case of friction piles, particularly in clay soil. No reduction in grouping occurs in end-bearing piles. The pile groups which are resisting the load by combined action of friction and end bearing, only the load carrying capacity of friction is reduced. The efficiency of the pile group can be calculated by using the following formula. The pile group efficiency is equal to the ratio of the average load per pile in the group at which the failure occurs to the accumulated load of a comparable single pile. This is example for converse Laborer formula. M is stand for number of row, N number of pile in a row, and D diameter of pile L, and S spacing of piles. Center to center spacing between piles in a group is kept between 2.5 and 3.5 where D is the diameter of the pile.
Now we continue the presentation with pile testing. Pile testing divide to three. First is dynamic load test. Pile load testing is a direct method for determining the geotechnical capabilities of pile. Dynamic load test with the aid of pile dynamic analyzer (PDA) is a fast, cost-effective, and reliable method for assessing foundation bearing capacity. Dynamic load testing provides information on the distribution of resistance, the edge resistance, and the end bearing. It also assesses the form and integrity of the basic element. The test can help you choose the right type of pile to withstand strain on the pile while driving, and be careful if the pile reach a specified length and can prevent unnecessary long pile. It also provides information on structural integrity, driving pressure, and hammer efficiency. The acceleration and stretching transducer are used by affixing them to the base to measure power and velocity when the weight decreases hit it. To produce a more accurate measurement of power and speed up, the test of power transducer usage. This is the photo of dynamic load test and PDA. Integrity test. Integrity testing is an important part of safety in either precast or cast-in-place concrete. Concrete pile and drill shaft are crucial categories of foundation. Although it's a bit expensive, they are important in the process to transfer the load of heavy superstructures such as tall building, bridge, and other into low layers. Characteristic of deep foundation and piles such as: first, physical dimension of pile, length or cross-section. Second, continuity of pile, presence or void or major cracks. Third, consistency of the pile material. Integrity test for cast-in-place concrete and precast concrete with ultrasonic method provide acceleration and velocity and low strain method. The primary shock wave which travel down the length of the pile is reflected from the toe by the change in density between the concrete and the substrate. Nevertheless, any incompetence and disability encountered within its length will be reflected and added to the written signal. A hammer is used for affect the pile head and the pile should be applied vertically. The echoes are recorded after several impacts are applied to the pile section for each individual effect with the use of motion or acceleration transducer. This apparatus will integrate acceleration to obtain the velocity and prepare signal conditioning. Because the test use echo or sound to measure the instability of the pole, the velocity and acceleration limit it to assess the portion of the pile that is under the gap that crosses the whole pile. This type of test is recommended to professionals who are specialized in piling. This is the photo of integrity load test. Static load test. Static load testing apply load gradually to a deep foundation element while measuring foundation movement. Static load tests are divided into three. First, axial compression. Second, axial tension. Third, lateral. Axial compression. Compression test using beam and frame overhead reaction with durability to load force by reaction stack or dead weight. Axial tension. Tension test can also use beam and frame for overhead reaction or using only the reaction beam buttress on the mat. Lateral. Lateral test can use a variety of reaction system and often or even pull the other side load test stack to perform two tests at the same time. These tests are usually performed for maximum load used to the same foundation design load or geotechnical failure. In the static load test, the test load will be used with a hydraulic jack against the can curve concrete block with the load measured with the calibrate pressure gauge and verified at the chosen pile. The pile solution will be recorded with the dial gauge listed on the reference beam to confirm the reading optical level be used. It will be tested with load increases followed to the standard required with load, times and completion record. The criteria for determining pile load are but are not limited to the following. First, the load at which settlement continue to increases without increase of load. Second, the load beyond which there is an increases in net settlement unbalanced to the increase in load.